Hi, today we're looking at Functional Skills Maths Level 1. This is the AQA January 2023 paper, and we're going to start with the non-calculator section. Question 1. Work out 4 squared. This is the little 2 up here, so the 4 squared means not 2 lots of 4, but 4 times itself. So we've got 2 4s, but then multiplied together. Well, 4 times 4, I've got 4, 8, 12, 16. So it's that one there. Question 2. Work out 1.345 times 100. Well, we're multiplying, so we're going to be making the number bigger. So that means the decimal point is going to be moving to the right. We've got 2 zeros, so it's going to move once, twice to the right, so it's going to end up in there. So we're going to have an answer of 134.5. Question 3. A fair ordinary dice is rolled. What is the probability that it lands on an odd number? Well, with a dice, you've got either 1, 2, 3, 4, 5, or 6. So 6 possible outcomes. We want odd numbers, so 1, 3, or 5. So 1, 2, 3 out of a possible 6. You could write it as a half, but you can leave it as 3 over 6 as well. Question 4. Work out 9 plus 15 divided by 3. So we've got to use our BIDMAS rules here. We need to do the division before the addition, so we want this bit first. Well, 15 divided by 3. Well, let's do our 3 times table. 3, 6, 9, 12, 15. So that's 5 times. So we can replace the 15 divided by 3 with a 5. So 9 plus 5. Now we just need to work out the total of this. We can start with the 9, count on 5, 10, 11, 12, 13, 14. Question 5. 6 times 17 equals 102. Use this information to work out 6 times 0.17. Well, if we look at how we get from 17 to 0.17, well, it's this decimal point. It's moving 2 places. So to get from 17 to 0.17, we're moving it 2 places of that direction. Okay, so we just need to do the same with the answer. We've got this sort of invisible decimal point at the end, move it 1, 2 places, and we end up with 1.02, which we can write on there. Question 6. Work out 2/5 of 30. Okay, well, let's work out 1/5 of 30 first of all. So 1/5 of 30 means 1/5 times 30, or it's the same as 30 divided by 5. So let's do our 5 times table. 5, 10, 15, 20, 25, 30. So that's 6 times. So if 1/5 of 30 is 6, 2/5 is going to be double that. So it's going to be 2 times 6. Well, 2 6s are 12. Question 7. Charity walk. Theo is taking part in a charity walk between the towns of Armville and Dendal. Theo will take 3 days to do the walk and walk between 2 towns each day. here is a plan of the walk. So day 1 is going to start at Armville and go to Bradleston. Day 2, he'll go from Bradleston to Catterley. And on day 3, he'll go from Catterley to Dendal. Now let's look at the actual question, which is over the page. Now we're told the scale diagram on the centimetre grid shows Theo's walk. Okay, so we've got this down here. So it's going from Armville to Bradleston to Catterley to Dendal. Is the walk more than 50 kilometres? You must show your working. Okay, well, we're told that 1 centimetre represents 4 kilometres. So that means that each of these, one part of this square is 4 kilometres there. Right, now, what you would do, well actually, let's split this up. We're going to need to do the 3 different distances separately and add them together. So we want this distance. So we're going to want to know what this distance is, what this distance is, what this distance is, add them all together and then compare them to 50 kilometres. I'm going to start with this one because this should be the most straightforward. We've got 1, 2, 3 boxes, or 3 centimetres on the grid. If we know each 1 centimetre is 4 kilometres, well then this, we need 3 lots of 4 kilometres. Or 3 fours, we've got 4, 8, 12. That's going to be 12 kilometres. Now for this one, it's nice and easy because they're straight lines. So we know that each one is 4 kilometres. For these, it's a bit trickier. Well, actually, this one's probably not too bad. Let's try. So we've got 1, 2, 3, 4, 5, 6 and a half. So this is, let's put this one. So 6 and a half or 6.5 squares, that is. Well, if each square is 4 kilometres, it's going to be 4, 8, 12, 16, 20, 24. And half a square, or half a 4, which is 2, will make it 26. So this distance is 26 kilometres. Now the hardest one to measure is going to be this one along here. Now in the exam, what you would need to do is use your ruler and measure it. Okay. Now this isn't going to work exactly here because when you print out the paper, it doesn't print it out exactly the same size as what you would get in the exam. But we're going to try it anyway. So if we look on here, actually this measures as 5 centimetres on here. So we'll go with this. We'll assume that it is 5 centimetres or 5 squares. Yeah, let's put 5 centimetres. But we know that 5 centimetres, or each centimetre is 4 kilometres. So 5 centimetres would be 4, 8, 12, 16, 20 kilometres. So now we just need to work out the distance. So we've got 20 kilometres, we've got 12 kilometres, and we've got 26 kilometres. So let's add these all up. 0 plus 2 plus 6 is 8. 2 plus 1 plus 2 is 5. So we get a total of 58 kilometres. So we can say 58 is greater than 50. So yes, it is more than 50 kilometres. You could do it slightly differently. You could do your total distance in centimetres and then multiply it by 4, but you should still end up with a similar answer. As I say, it might just depend on how it's printed out. You might get slightly different to this, but don't worry, in the exam, so long as you know the thing that you do, you would measure them and then use the scale to convert the centimetres into kilometres. Alright, question. Oh, we're not going to fit it all in. We'll have to move it up as we go along. Question 7b. On the walk, Theo comes to a gate in an L-shaped field. Here's the gate here. We've got the distances of some of the sides, and we've got a stile over here. Theo has to walk from the gate to the stile. He can only walk along the sides of the field. Theo can walk along two sides, so here and here, or walk along four sides. 1, 2, 3, 4. How much, or let's move this up. How much shorter is it to walk along two sides? So let's work out this distance first of all. So we've got the distance along the top. We want to know what this distance is. So to work out this distance, we can say, well, we know this full distance down here, and we know that this bit is 760 metres. So this would, if we do a dotted line across, we're saying this bit is 760. So this bit up here, which is the same as this bit over here, must be the full distance, 1040, minus 760. So 0 minus 0 is 0. 4 minus 6 you can't do. We can't take 1 from the 0, so we have to reduce that 1 to nothing and pass 1 across. We still want to get a 1 in front of the 4, so we reduce the 10 to a 9 and make this 14. So 14 minus 6 is 8. 9 minus 7 is 2. So this distance is 280 metres. So that means the distance walking along two sides must be 1,360 plus the 280 we just worked out. 0 plus 0 is 0. 6 plus 8 is 14. 3 plus 2 plus 1 is 6. And 1 plus nothing is still 1. So we've got 1,640 metres. Or he can walk along four sides. So that would be this distance, so the 1,040, 850, 760, and this extra distance along here. So another distance which we haven't got. This time we're going to look at the distances in this direction. So it's going to be 1,360 would be the full distance across. But we don't want this section here. We already know what this section is. So we can subtract 850. So 0 minus 0 is 0. 6 minus 5 is 1. 3 minus 8 we can't do. But because it's just the 1 here, we can reduce it to a 0, pass it across. Or we could have just kept it and said 13 minus 8, which is 5. So we've got 510 metres. So I'm just going to draw a little arrow up here. So the four sides would be 1,040 plus 850 plus 760 plus the 510 we've just worked out. All the zeros are still 0. 4 plus 5 is 9. Actually, I'm going to add the 1 on next to make it 10. Plus 6 is 16. 0 plus 8 plus 7 is 15. Plus 5 is 20. Plus 1 is 21. 1 carry the 2. And 1 plus 2 is 3. So we've got a total of 3,160 metres. Now they asked us how much shorter is it to walk along two sides. So in other words, what's the difference between these two measurements? So we need 3,160, so the bigger measurement first, and we're going to subtract the smaller measurement. 0 minus 0 is 0. 6 minus 4 is 2. 1 minus 6 we can't do because 6 is bigger than 1. Reduce that to 2, so we've got 1 here. 11 minus 6 is 5. 2 minus 1 is 1. So our answer is going to be 1,520 metres. And question 7C. People pay to take part in the charity walk. The normal cost is £36 per person. But there's a group discount. A group of 4 or more, the normal cost is reduced by 10%. Theo is in a group of 7 people. Work out the total cost for the group. Well, let's start off with the unreduced price. So there's 36 of them. Sorry, it's £36, but there's 7 of them. So we want 36 times 7. So we'll start off with 7 times 6, or 6 times 7. I'm going to do 7 sixes, because I think 6 times table is a bit more straightforward. 6, 12, 18, 24, 30, 36, 42. 7 sixes are 42. Then we want 7 times 3, or 3 times 7. I'll do 3 times 7. 7, 14, 21. Plus the 4 is going to make it 25. So we've got £252 so far, but it's reduced by 10%. Okay, well, we want 10% of 252. Well, 10%, that means we're dividing by 10. So we're just going to move that decimal point into there. So in other words, it's going to be £25.2, but because it's money, we need to make it £25.20. So this is the group discount. So we've got to take that away from £252. So 252 subtract £25.20. And you'll see I've lined up the units and the tens. Now, so that we've got something to take the 20p away from, I'm going to put zeros in there as a placeholder. So 0 minus 0 is 0. 0 minus 2 we can't do. So make that a 1. Now we've got 10 minus 2, which is 8. Bring down the decimal point. 1 minus 5 we can't do because 5 is bigger than 1. So reduce that to a 4 and make that 11. 11 minus 5 is 6. 4 minus 2 is 2. 2 minus nothing is 2. So they've already given us the pound sign here. So £226.80. And that's the end of the non-calculator section. Okay, now for the calculator section. Question 1. Circle the shape that has only one line of symmetry. So we know a line of symmetry is a line that splits a shape equally in half with a mirror image. So in other words, the square's got a line of symmetry there because this piece would fold perfectly onto this one. But it's also got a line of symmetry here. It's also got a line of symmetry on this diagonal and this diagonal. But it says only one line of symmetry. So it's definitely not that shape. Well, what about line of symmetries for a circle? Well, you can split it down the middle that way. You can split it horizontally. In fact, with a circle, you've got an infinite number of lines of symmetry because you could do all of these and one half would perfectly match on the other. So it's not going to be that shape either. What about with the triangle? Well, this looks like an isosceles triangle to me because these angles look the same. So we could split it down the middle. And I think that's the only one we could do. So it's probably going to be this one. But let's check. What about this shape here? It looks like we've probably got a rhombus here, especially if all the sides are the same. But we can definitely split it vertically and horizontally. So it can't be that one either. It must be our isosceles triangle there. Question 2. Put the following decimals in order, starting with the largest. Right, well, they're all starting with a 2. So we can't tell anything just by looking at the whole numbers. We're going to start to look at the decimals. Well, we've got 4, so these are the tenths. We've got 4 tenths, no tenths, 6 tenths, or 7 tenths. Well, 7, this has got the most amount of tenths, so it's going to be this one first, 2.702, so we can tick that one off. So again, we'll stick with the tenths, 4 tenths, no tenths, and 6 tenths. So 6 is the biggest on the tenths. That comes next, and we can tick it off. So 4 tenths or no tenths, well, it must be this one, 2.45, and finally 2.035. Question 3. Write in digits the number 3071. Right, so 3071. Now you might think 3071, but that doesn't look quite right. But then if you think about what each of the digits represents, we've got thousands, then we've got hundreds, then tens, and then units or ones. Well, we haven't got any hundreds. Well, we can't just leave it blank. So we need to put a 0 in there because we haven't been told about any hundreds. Question 4. You are facing east. You turn 180 degrees. What direction are you facing now? So let's draw some quick compass directions. We'll have north up at the top. And on a compass, we always have never eat shredded wheat. North, east, south, west. Okay, so if you're facing east, so you're here, you're looking that way, you turn 180 degrees. Now, it doesn't tell us whether it's clockwise or anti-clockwise, but 180 degrees means you're looking in the opposite direction. So it doesn't matter which way round we go, we're still going to be pointing at west. Question 5. Complete the table to show equivalent fractions, decimals, and percentages. So we want this written as a fraction, 0.65 or 65%. Well, 65%, that means 65 out of 100. 7 tenths or 0.7 as a percentage. Well, what we can do to turn it from a fraction to a percentage, I'm going to use a calculator and I'm going to say 7 divided by 10. Make it a percentage, we multiply by 100. So we get 70%. Question 6. Here are 20 values. Okay, 6, 8, 4, 2, 5, all that across. Complete the grouped frequency table with the tallies and frequencies. So, values, all the values that are between 1 and 3, all those between 4 and 6, between 7 and 9, and 10 and 12. You can go through them one at a time. So you could say 6, I'll put 1 for 6, 8, 1 for 8, which is fine. I prefer to say, well, I want all the values between 1 and 3. So, no, yeah, that's 1, no, it's 2, 3, 4, 5, 6, 7, 8. And just go straight for the frequency. And then the tally is going to be 1, 2, 3, 4, 5, 6, 7, 8. So you can do the frequency first and then the tally, or the tally and then the frequency, is up to you. But as I say, I find it easier to say, right, I want all the values between 4 and 6. So 4, 5 or 6. So we've got 1, 2, 3, 4, 5. So we've got 5 there. So that was 1, 2, 3, 4, 5. Then what about the values between 7 and 9? 1, 2, 3, 4, 5. And the reason I'm crossing them off is that because then at the end I can make sure I've crossed them all off and I haven't missed any out. So the values between 10 and 12, these have all been used. 1, 2. There we go. And if we want to check, we can make sure that these all add up. So 8 plus 2 is 10, plus 5 is 15, plus another 5 is 20, and there's 20 values. So that looks good to me. Question 7. Here is an L shape. We've got the measurements for all of the sides on here. Work out the area of the L shape. So the area is a space inside. So what we're going to have to do is break this up into rectangles. So we could split it here. So we've got one up on top and a long one at the bottom. Or I'm going to split it down this way. So I've got one rectangle here and one rectangle down here. Another way you could do is work out the big rectangle and then take away this bit outside. But I'm going to add them together instead. So first of all, I want the area of this rectangle, and the area is the length times the width for a rectangle. So my length is 9 centimeters and my width is 8. So you might know this one, but we can check with our calculator. 9 times 8 is 72. And its area, so it's going to be centimeters squared. This rectangle down here, the area is going to be the 5 times the 3, which is 15 centimeters squared. So the area is going to be these added together, so it's going to be the 72 plus the 15. We've already got 15, add the 72, it's 87 centimeters squared. Question 8. A party. Gemma is planning a birthday party for her daughter. 8A. Gemma will hire a hall for the party. And we've got a little advert there, hall for hire. £15.75p per hour, plus £32 cleaning charge. Gemma will hire the hall so that she has 30 minutes to set up before the party from 4:30 p.m. to 6:30 p.m, and 30 minutes to tidy up after the party. Is £80 enough to pay for the hall hire and the cleaning charge? You must show you're working. Right, so how long do we need the hall for? Well, we've got 30 minutes, so we can think of that as half an hour. 4:30 to 6:30, or 4:30 to 5:30 would be 1 hour, to 6:30 would be 2 hours, so 2 hours there, and 30 minutes to tidy up after the party, so that's another half hour. So a half plus a half is a whole, so 1 plus 2, 1 plus 2, that means we've got 3 hours in total. So to work out the total cost, we're going to need 3 hours at £15.75 per hour. Which is £47.25. Then we've got to add on the cleaning charge, which gives us a total of £79.25p. And that is less than £80. So is £80 enough? You've got to make sure you answer the question as well. So we can say yes, £80 is enough. Now, if you just worked it out without saying this, you'd only get 3 marks. So make sure you answer the question that they're asking. (8b). Gemma orders pizzas for the party. Each pizza has 8 slices. Each person will get 3 slices. How many pizzas should Gemma order for 30 people? Right, so 30 people, each one getting 3 slices. So 30 times 3. This will tell us the total number of slices. So 90 slices. Okay. Each pizza's got 8 slices. So how many pizzas do we need? Well, we can do 90 divided by 8. That's how many 8s we can fit into this. So 90 divided by 8 is 11.25 pizzas. But we can only buy a whole number of pizzas. Well, if we buy 11 times 8 is only 88. It's not going to be enough. So we need 12 pizzas. It does mean you'll have a little bit left over, a few extra slices, but that's not a bad thing when it comes to pizzas. So we can write 12. (8C). Gemma makes a fruit drink for the party. She uses this recipe. Mix cranberry juice and orange juice in the ratio. Cranberry to orange is 1:4. Gemma wants to make 280 millilitres of the drink for each person. She has 2 litres of cranberry juice. She has plenty of orange juice. In other words, we're saying I think there's no limit on orange juice. Does Gemma have enough cranberry juice to make the drink for 30 people? You must show your working. So let's start out by working out how much drink do we need in total. Well, if it's 280 millilitres per person, 280, there's 30 people. So multiply that by 30, that'll tell us the total amount we need, which is 8,400 millilitres. Right, so now we know how much we need in total. We've got a ratio. We can draw a ratio table. Right, and the ratio we've got is cranberry, orange, and we're going to give ourselves a total. So the ratio was 1 cranberry to 5 orange. To 4 orange. Yeah. If we only had 1 cranberry and 4 orange, we would have a total of 5. In fact, the total that we've got, we've got, what have we got here? 8,400. That's how much we're trying to make. So we want to know how we get from one row to the next. So we do it in reverse. So we say 8,400 divided by 5. That'll tell us how we're getting up. So we've still got 8,400 in the calculator. Divide it by 5. We get 1,680 millilitres. That's what we increase it by. So if we want to know how much cranberry juice we need to multiply that by 1,680. And because we're just multiplying it by 1, we're going to get 1,680 millilitres. She has 2 litres of cranberry juice. Well, we've got litres and we've got millilitres. So let's convert this into millilitres. Well, I know that there are 1,000 millilitres in 1 litre. So 2 times 1,000 is going to be 2,000 millilitres. So she's got 2,000 millilitres. She needs 1,680. Well, what she's got is bigger than what she needs. So, yes, she has enough. Question 9. Pets. The weight of Nina's dog has increased from 5.4 kilograms to 6.1 kilograms. Nina says his weight has increased by more than 15%. Is Nina correct? You must show you're working. Right, let's work out how much it has increased by. So start with the bigger number, subtract the smaller one. This will tell us the amount of the increase. 6.1 minus 5.4 is 0.7 kilograms. Well, what's that as a percentage? Well, it would be 0.7 out of the original weight, which was 5.4. And if we want to turn it into a percentage, we then multiply that by 100. So 0.7 divided by 5.4 times 100, 12.96. If we're talking in whole numbers, we can say, well, that's 13%. Well, 13% is less than 15%. So his weight has increased by more than 15%. No, that's not true. (9b). Jack is a vet. He collects this information about 20 pets that he sees. So he sees 10 dogs, 6 cats, and 4 rabbits. Draw a suitable diagram to show this information. And we've got some graph paper down here. Okay, so I'm going to draw a bar graph. When we've got a number of things that we're counting, a bar graph's usually the easiest way to do it. And I'm going to do a vertical bar chart. You could do a horizontal one, but you tend to do vertical. So I'm going to have 3 categories: dogs, cats, and rabbits. I'm going to start in the graph paper. Some people like to start on the outside, some start on the paper. It doesn't matter as long as it fits nicely on the page. If we've got 3 categories, I could do 2 of these big squares. Let's think, we could have 1, another 2 big squares, another 2. Yeah, that would fit. Just make sure, yeah, everything fits on and you've got your bars the same width. Everything nice and tidy. So down at the bottom, we're going to have our type of pet. So dog. And I'm keeping the animals in order: dog, cat, rabbit. No need to change the order. You don't need it by size or anything. Just keep them in the order they've given them. And then we've got the number of pets. So this is going to have to go up the side here. Now the biggest number we've got is the 10. So we need to go up to at least 10. So what have we got? 1, 2, 3, 4, 5, 6. No, that's going to go off the page. What about if we use these smaller ones here? We could have, we're always going to start at 0. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that would fit. And when we're writing the numbers on, we don't have to write every single number. We can just go up in 2s. And then we need a label over here. So this is going to be our number of pets. In the exam, you might choose to do graph questions at the end, or maybe drawing the graphs, just because they can take a bit longer, but it's entirely up to you. So we've got 10 dogs. So dogs need to go up to 10 here, and it's the width of 2 of those boxes. Cats, we've got 6 cats. So we're just going to go up to the 6 here. Now use your ruler, keep this all nice and tidy. And I like to make my bars the full width across. You can make them smaller if you want to. And rabbits, we've got 4 rabbits. So we're going to go up to 4, which is here. And the only thing that's missing is a title. So we're just going to put Vet's Pets. Nice catchy title. Question 9C. Millie keeps fish. Her tank is a cuboid with length 45 centimetres and width 30 centimetres. The depth of the water in the tank is 40 centimetres. That's here. Millie needs to add 2 millilitres of a chemical for each litre of water in the tank. And we're told 1,000, that's why it's good to put the commas in, 1,000 centimetres cubed equals 1 litre. How many millilitres of the chemical should Millie add to her tank? Well, so the first thing we need to do is to work out the volume, not of the whole tank, but of the water. Okay, so we want the volume. And the volume of a cuboid is equal to the length times the width times the height. So that's going to be 45 times 30 times 40. Which gives us 54,000. And that's going to be centimetres cubed. Right, now we need to go from centimetres cubed into litres. We know 1,000 centimetre cubed is 1 litre, so we want to divide this by 1,000. Oh, pressed the wrong button. 54,000 we had. Divide it by 1,000, we get 54. So that's 54 litres. Okay, Millie needs to add 2 millilitres of a chemical for each litre of water. We've got 54 litres, so we want 54 lots of 2 millilitres. So 54 times 2 gives us 108 millilitres. Question 10. The cafe. Marcia owns a cafe. The cafe is open 7 days a week. Marcia needs a part-time assistant each day. She can afford to pay the new assistant £160 per week. The hourly rate of pay is £9.60. She will employ the assistant for the same number of hours each day. For how many hours can Marcia employ the new assistant each day? Give your answer as a decimal. Okay. If it's open 7 days a week, the first thing I'm going to do is split my £168 into the days. So how much have we got to spend each day? Because remember they said she'll employ the assistant for the same number of hours each day. So divide it by 7 first of all. This will tell us how much money she's got to spend per day. So that means 24 pounds per day. Okay, £24, and she's got to pay £9.60 an hour. So if we divide it by £9.60 or 9.6, that's going to tell us how many hours they can employ them per day. So 2.5 hours. (10B). This is part of the menu from the cafe. We've got the menu there. We've got coffee is £2.99, tea is £2.25, and a toasted sandwich is £3.80. There is a special offer on toasted sandwiches. We've got a special offer, toasted sandwiches, buy one, get one half price. A customer orders 1 coffee, 1 tea, 2 toasted sandwiches. He pays with a £20 note. How much change should he get? Okay, well, let's work out what each of these things are going to cost. So 1 coffee, that was £2.99. 1 tea, that's £2.25. Let's put the pound sign in. 2 toasted sandwiches. Well, they're £3.80 each, but remember, buy one, get one half price. So for 2 of them, it's going to be £3.80 plus £3.80 divided by 2, which we're only paying for half of it. So this bit, the £3.80 divided by 2, is going to be £1.90. So the total cost is £2.99 plus £2.25 plus £3.80 plus £1.90. And that gives us a total of £10.94. But don't stop there, because what they've asked us is how much change he should get from a £20 note. So starts with £20, spends £10.94. That's going to leave us with £9.06. C. This table shows the number of customers who visited the cafe in 1 week. So 45 on Monday, 64 on Tuesday, and so on. Marcia says the mean number of customers per day that week was more than 75. Is Marcia correct? You must show you're working. So we want to work out the mean. Well, the mean is equal to the total divided by how many you've got. Well, the total is going to be all of these added up. So 45 plus 64 plus 74 plus 41 plus 83 plus 120 plus 77. Now, what you might want to do, especially in any exam, is do that calculation a couple of times just to check, 'cause it's very easy to type something in wrong. So just to check that you get the same number. 504. How many? We've got 1, 2, 3, 4, 5, 6, 7 days. So 504 divided by 7, which gives us 72 customers. Marcia says the mean number of customers was more than 75. Well, 72 is less than 75. So is Marcia correct? No. Marcia is incorrect. Question 11. Cake company. Nico sells cupcakes in boxes. Nico wants to make an individual cupcake box with a lid out of a sheet of card. The cupcake box will be a cube of side length 8 centimetres. He will cut out a net of the cube to make the box. The square grid shows the piece of card he wants to use for each box. Draw a net for the box to check that this piece of card is large enough. One part of the net has been drawn for you, and that's that square in the middle. Now there's a lot of words here, but the key thing is draw a net of the box. And we're told the box is a cube, side length 8 centimetres, and it's with a lid. So basically we just want the net of the cube. And we've got a starting point. So if we're going to draw a cube, actually I'm going to draw a sketch before I do it more accurately on there. So cube, just like a dice, if you think easiest way to do a cube is to have 4 squares in a line, which will wrap round to go from top to bottom. And then we're going to have 2 on the side. So it's basically a cross that we want. But we've got to draw it accurately here. So, well, let's put one box on top. So 4 centimetres. So 1, 2, 3, 4. Do the same on this side. Where should we put the others? Probably got more space to put them down here. So if you remember with my sketch, 1, 2, 3, 4. I had 4 squares in a row vertically. 1, 2, 3, 4. Now there are other ways to draw a net of a cube, and any of those would be fine. I just find this the easiest. So I've got my 4 squares in a row. Then I want my 1, 2, 3, 4. So my flaps on the side. 1, 2, 3, 4. And if I'm going to be efficient, I'm going to do 4 there. 1, 2, 3, 4 on that side. There we go. Okay, now they said represents a 2 centimetre by 2 centimetre square. We could use this and we could say, well, 8 divided by 2 is 4, but actually, because they'd already drawn a square for us, that scale doesn't really matter. We just make sure that all of our squares are going to be the same size as this one. So all of them are 4 squares by 4 squares. (11b). The table shows the number of boxes of cupcakes in one order from a customer. So there were, for small cupcake boxes, they're £3.15 per box, and 5 of them were ordered. For medium ones, they're £10.75 a box, and 4 were ordered, and the large ones are £15.45 a box, and 2 were ordered. Nico charges a handling fee for this order. The handling fee is 20p per box plus £1.50. Work out the total amount, including the handling fee, that this customer has to pay. Right. So let's work out the cost of these first without the handling fee. I'm going to do this bit afterwards. So we've got small ones. We've got 5 at £3.15. So basically we're going to multiply those together. So £3.15 times 5, or 5 times £3.15. So all of the small ones are going to cost £15.75 altogether. We're going to do the same for the medium and the large. So the mediums are going to be 4 times £10.75, or £10.75 times 4, whichever way, £43. And £15.45 times 2, 30.9, but because it's money, we need to make it £30.90. So now let's work out the total of these. Add the 43, add the £15.75, and we get £89.65p. But we haven't done a handling fee yet. Now the handling fee is 20p per box, plus £1.50. It doesn't tell us, it doesn't change per box according to this, it's just how many boxes. Well, we've got 5 plus 4 plus 2. You can use your calculator, but that's 11. So 20p times 11, well, because it's money, I'm going to do it as £0.20. That's 20p. We're going to multiply that by 11, and then we're going to add on £1.50. So 0.2 times 11 would be 2.2 or £2.20. Add on the £1.50. 3.7 or £3.70. So the total amount, well, it's going to be £89.65 plus the £3.70 handling fee. Oh, I don't know why I put equals there. 3.7 is already in there. Add on the 89.65. We're going to get £93.35. 11c. The pie chart represents the income from the sale of boxes of cupcakes last year. So the biggest section was the income from the large boxes, then the small boxes, and medium gave us the smallest section. A bit confusing because we got small is a medium and medium is small. But most were large, then small ones, and then medium. The total income from the sale of boxes of cupcakes was put the comma in there, £16,200. Nico says the income from large boxes of cupcakes was more than £10,000. Is he correct? Okay, so we've got to work that out. Now, with this one, we've got some angles, so we want to work out angles here, but we don't need to use a protractor because they've told us this is 60 degrees, and this is a right angle here, so it means that's 90 degrees, and we know that angles in a circle are 360 degrees. So if we want to know the angle measurement here, well, it's going to be 360 minus 90 and minus 60. If you want, you can add the 90 and 60 together and then take them off in one go, or you can take them off one at a time. So minus the 90, minus the 60. So that is 210 degrees. Right, so £16,200 is for the whole pie chart, the whole circle. We only want, well actually, there's a couple of different ways of doing it. I'll show you one way first. We want 210 degrees out of 360 degrees of the total, so times 16,200. Okay, so 210 divided by 360 times 16,200, and we get 9449.999, or in other words, if we round that up, it's going to be 9,400, and that 9 would make that, as instead of 49, we're going to have 9,450, which is less than 10,000. So we can say, is he correct? No. Now, if you're not comfortable using this fraction here, what you can say is you can think of it of 1 degree. So you can think 16,200 is for 360 degrees, is for everything. So if we divide it by 360, it's going to tell us how much it is for 1 degree. Okay, so that's £45 per degree. Per 1 degree. We know we've got 210 of them, so we can do 210 times 45, or 45 times 210, and that gets us nice and easy to 9,450. Which is still less than 10,000. So actually, I think I prefer this method. So I'm going to do this as alternative method. Either way is fine, and you might find a different way to do it as well, but I think this is probably nicer. We're working out how much money for 1 degree and then multiplying it by the number of degrees that we've got. But you still need to do this calculation. You still need to work out that angle there. And finally, 11D. Nico opens a new bank account. He puts £295 into the account. 5% interest is added to the account each year. After 1 year, Nico takes £269 from the account to buy a new mixer. How much is left in the account? Right, well, it was after 1 year, so how much had the account grown to by then? Well, we've got 5% to add on to that. So 5% is 5 out of 100 times 295. This is the amount of interest they earned in the first year. Which is £14.75p. So that means the value after year one would be 295 plus £14.75, which gives us a total of £309.75. But he spent £269. So if we take off £269, we end up with £40.75, which we can write down here. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on. Let me know if you've got any questions, and I look forward to seeing you again soon. Thank you.